Hello everyone, today we're going to be doing a chemistry question. Calculate the pH of 0.1 mole per decimeter cube of potassium ethanoate, and we're given the Kb of the ethanoate ion. So let's first write down the dissociation of potassium ethanoate, which is KCH. COO. Okay, and we know that potassium does not have any acid-base activity in water, but the ethanoate ion does because it's a weak acid. So that means that it will undergo hydrolysis. So CH3COO minus plus H2O times the concentration of the hydroxide ion all over. We don't count H2O here. And now let's form the icebox. So initial concentration of CH3COO minus is 0.1 mole. That makes sense. And for CH3COOH is 0, same for OH minus 0. The change is going to be negative x, and plus x. And so the equilibrium would be 0.1 minus x, and x. And so 5.6 times 10 to the negative 10 equals x squared over 0.1 minus x. But we know x would be really small here because the dissociation is very small, so the change would be very small. So we can really just neglect this change. So it would just, so x squared would be 0.1 times 5.6 times 10 to the negative 10, which means x would be the square root of this. And now we can put this into the calculator. And we're getting 7.5 around 7.48 times 10 to the negative 6. And we know that this value would be the concentration of the hydroxide. So we can write this. And we want the pH, so pH equals negative log And that would be 10 to the negative 14 because it's negative log the hydrogen ions. Oh, sorry. This is 10 to the negative 14 over 7.48 times 10 to the negative 6. Oh, I wrote 6 back here, but it should be negative 6. And now we can put this into the calculator. And we get a pH of 9 to the 1 significant figures. And that is our final answer. Thank you.